Good afternoon, I'm Alex Beaumont, the Outreach and Engagement Coordinator at the Business and Local Government Data Research Centre. Welcome to our webinar today, which will be Understanding Open Source GIS with Professor Andrew Lovett from the University of East Anglia. Today, Andrew will discuss developments in open source GIS, in particular reviewing data and software sources. Andrew will speak for about 40 minutes. We will then address any questions which you have afterwards. You can submit your questions throughout the webinar via the questions box in the panel on your right. I'll pass you straight over to Andrew to get started. There we go. Just giving you access to the screen. There we go, Andrew.
Is that okay, Alex?
Yep, that's perfect.
Okay. So good afternoon, everyone. As Alex says, what I'm going to discuss for the next 40 minutes or so is some of the recent developments in open source GIS. And so I'm going to talk about the following main things. I'm going to provide a little bit of background about what GIS is and some of the key drivers for open source developments. I want to talk a little bit about what we mean by open source data. What are some of its key kinds of characteristics and the different types of open source spatial data that exist. I want particularly to talk about the characteristics of an open source spatial data set called OpenStreetMap, because this is basically now one of the most widely used resources around the world. So I want to talk about some of its characteristics, and I'm also planning to sort of demonstrate on my screen what some of that data looks like. Once we've talked a little bit about data, I'll also discuss open source software and some of the ways that that is developed. There's a very large variety of open source GIS programs now, and I'll show you a resource where you can find out more about those. But I'm then going to focus on one of the most widely used ones, which is the QGIS software. I'm going to give you a little bit of an online demonstration of the QGIS software to give you a sort of sense of what it looks like, the kinds of things you can use it to do, and because many of you will probably be familiar with the Esri ArcGIS software, which I talked about in a previous webinar, I'm also going to make some particular comparison points between ArcGIS and QGIS. And then, as Alex said, we will have some time for questions at the end. So without further ado, what's a GIS? Well, this is a diagram taken from the textbook by Paul Longley and colleagues, which I think summarizes quite effectively the sort of the circle of data processing and decision making that we go through with a GIS. So essentially we have different sorts of real world features which we want to encapsulate information about. We decide how we're going to describe and represent those in terms of data models and structures within a GIS. So for example, vector data structures in terms of points, lines and polygons, or raster data structures in terms of grids of differing sorts of resolutions. Having defined those sorts of features, we can import them into the GIS program. We can use the GIS to undertake a large array of different types of spatial analysis, present the information in different forms such as maps and tables and graphs, and ultimately that can be employed by a range of users to help interpret different types of information and make decisions, which then in turn actually obviously sort of feeds back onto the real world that we're dealing with. Now the circle that you see there is obviously something that relates to the history of GIS. But if you go back, certainly in the UK, much more than 10 years or so, the great majority of the data that you would be using would have basically been information that was licensed from, for example, government agencies or businesses. And in some cases, there would definitely been a cost involved in acquiring that information. And there would have been a number of restrictions about the extent to which you could use it, supply it on to other people, and so on and so forth. And the same is also very definitely true of the GIS software, because GIS has certainly for a long time been dominated by proprietary software from companies like, for example, ESRI, ESRI, MapInfo, Autodesk, Intergraph, and so on and so forth. And one of the really substantial changes in GIS in the last 10 years has been, I think, firstly, the diversity of data sources, and particularly source organizations that we have now, and if you like, in some ways, the democratization of data in terms of who can create data and make it available to other people. And similarly, there's a democratization element in the sense that the cost of acquiring GIS software and using it has also been reduced in all sorts of ways, and the development of open source GIS platforms has very definitely been important in transforming that. So the kind of cycle that you can see there has been very much influenced by these types of development. In terms of what we're thinking about, what has driven all of this? Well, I think there's two main sorts of elements. There's no doubt that a lot of this has been driven by different sorts of technical innovations. So some of those are to do, for example, with the availability of better global positioning system signals and how that has supported the ability to go out and map your own features in a very accurate and reliable way. We have better handheld IT capabilities in terms of smartphone apps, panel computers, and so forth. And of course, we have a much greater internet infrastructure than we had a number of years ago, which not only means can you create data, but you've now got platforms that are much, much better at supporting online collaboration and dissemination. And that's been very important, both in terms of making different sorts of data sets more widely available, but it's also been absolutely fundamental in terms of allowing communities of interested parties to work together on software development. And that, I think, has been a crucial thing in terms of open source GIS, because the key feature of the developments in the past 10 years or so has very definitely been the improvement in the quality, the ease of use, and the access to those sorts of software tools, and that's very definitely been facilitated by those kinds of technical developments. As that's been going on, there's also been wider recognition of the economic and social benefits to society of having more open source software, and particularly having more open source data. So there have been initiatives across many countries. So for example, in the EU, one of the key pieces of legislation has been the Inspire Directive of 2007 and how that's subsequently been implemented. But that has been a key factor in terms of making many different types of data sets that were previously held by government departments and agencies in the UK now available much more freely and on much more open license conditions. So it's much easier to do things with the data. In some ways, what that has done is even up some of the differences that existed previously between different countries. So, for example, attitude to public data in the United States of America and the UK was very different for a long time in terms of what you could do with the information. The UK system was more restrictive, and those differences are definitely reducing over time. They've not disappeared completely, but they're very definitely less different than they were. And so that's had implications for two key elements of that GIS cycle. It's had implications in terms of the data that are available, and it's had implications in terms of the software. There's been open source software for a number of years. You can find examples going back to the 1980s, but there's been an enormous growth in these types of developments in the past decade or so. So let's look at a little bit more in terms of some data examples. I think you can sort of think about these under two main types of headings. So firstly, you've got previously licensed data where there might have been a cost or a quite restrictive license associated with obtaining the data. That information is now in the public domain. It doesn't cost anything to obtain it, and the licensing restrictions associated with its use are much wider, much more generous, if you like, than what they were previously. So you can see that in terms of, for example, the amount of data from organizations like the Environment Agency that is now placed on data.gov.uk. And a good example of that in the spatial data realm would be the availability of LiDAR, very detailed digital surface data and terrain data for many parts of the UK. And you can also see the same sort of thing for many different organisations. So, for example, the British Geological Survey have an open geoscience site. The Ordnance Survey have a large open data resource. They don't have all of their products in that category yet, but it's an enormous change from the situation in Ordnance Survey data going back a few years. So firstly, you have information that's been sort of put into the public domain. And then secondly, you have very substantial developments going on in effect outside those established data providers, where you in effect have different types of crowdsourced database creation. So you have individuals and groups collaborating together to create different sorts of spatial databases. And one of the most substantial of those is the OpenStreetMap project, and I'll talk a bit more about that and demonstrate that in a minute. But I think it's also useful to think about the sorts of license terms that exist. So what I've put on the screen now is the UK Open Government License version 3 that came into effect in 2014, because I think this shows, how things have changed in terms of what you can now do with this information. You can copy it, you can transmit it. Very importantly, you can exploit the information commercially, combine it with other information, and include it in your own product and application. That is very, very different from the sorts of terms that existed a number of years ago. If you do this, you do need to acknowledge the source of the information, but in terms of allowing the information to be used in a much wider range of ways, support commercial applications, allow it to be redistributed and so forth, we have moved an awful long way in this direction in the last few years. There are some sorts of things that are still not covered by these licenses. So, for example, it doesn't cover any sort of personal data in the information. It doesn't include some sorts of things that have been obtained under, for example, Freedom of Information Acts and things of this sort. And there's still some sorts of intellectual property rights associated with some of these data. But it's very definitely opened up a very, very large data resource to much wider use than was previously the case. So let's look at an example now of a crowdsourced data set. So I would have said that by far the largest of these at the moment is OpenStreetMap, and you can see the website for that on the screen if you want to look at that on your own computers. You're looking at the moment at the OpenStreetMap view for the University of East Anglia on the southwestern side of Norwich. So you can see the UEA here, the main Norwich Hospital, various residential areas and so forth. This data set is straightforward to access. It has become very detailed. It's sort of, originally was established in 2004. It was sort of stimulated by the success of Wikipedia. If you look on the OpenStreetMap website now, it's got over 3 million registered users. It's become a very, very substantial resource for these types of applications, and it's something that's relatively straightforward to include in your own analyses and work and so forth. The data is structured in a number of different ways. Firstly, the different features that you can see are built up from some core data primitives. So the idea of nodes, point features, ways, linear features and boundaries, and relations, which are concepts that are used to sort of link features together. So this might be different types of routes, networks, junctions, and so forth. And those are the sort of, if you like, the kind of spatial data elements. And then those spatial data elements can have associated with them a number of different tags that represent the attribute, the information. And they take the form, the sort of a keyword equals a particular value. So the tags are what you use to tell the software and the data set, what is this type of point feature or line feature. So you might have a tag along the lines of highway equals residential for residential street, or natural equals tree, or something of that sort. There are a huge variety of different sorts of tags that you can use. I've included on the slide a number of two websites that I found very useful for looking at different types of tag information. So you can see the links there, particularly if you're looking at how different types of tags are used in the UK and understanding what that might mean for the interpretation of the information you're looking at. Those sorts of sites tend to be quite useful. So there's an enormous database there. It's very definitely got certain advantages. And I would highlight the ones that you can see on the slide now. It's often updated incredibly rapidly. So, for example, the information about the University of East Anglia campus has buildings that have only been opened in the last sort of 6 months. And often I've found that, for example, the OpenStreetMap data is more detailed and more up-to-date in terms of features like footpaths and buildings and so forth than some of the types of Ordnance Survey products. It's a database that's worldwide in scope. It's a database that builds very much upon local knowledge. That is very striking if you look at databases, information for example, cities in other parts of the world. So in Nairobi, for example, there is a large urban slum area called Kibera. The mapping of the buildings and services in Kibera is much more detailed on local street map than any sort of official government or international agency database I've ever seen. And that has come from a combination of a local community group initiative, the availability of things like global positioning based mapping tools, smartphone apps or little GPS receivers that enable that local mapping to take place, and the ability to upload it to repositories like OpenStreetMap that can then enable much wider dissemination of those types of resources. And equally, one of the other advantages is any feature can be tagged in a number of different ways. So often you have more information, more detail about certain types of features in, for example, a town or city than would exist in terms of, for example, the coding on some of the types of ordnance survey products. You get more, you just get more detail about certain types of things. However, there's some potential drawbacks that I think it's important to be aware of. With this kind of crowdsourced data, one of the key issues is that obviously you're going to get geographical variations in collection effort. You may have individuals and communities who are interested in mapping their town or a particular neighborhood in a great deal of detail, but that doesn't mean that the same thing has happened in the neighboring town or another part of the city. And I'll show you some examples in a minute with data for London where you can really see that there's differences in the amount of detail in the data. Sometimes there's variable data quality in terms of the accuracy with which features have been mapped. And there can be a number of sorts of inconsistencies in the data. And these refer both to the sorts of spatial elements of the data and also the attribute information. So some of these referring to spatial features are in terms of how well the topology, the connectedness of features is defined. So you may have a polygon feature that actually isn't completely closed, what you'd call a broken polygon, or you may have polygons that overlap so that you have sort of sliver type features and so forth. And one of the consequences of that is the features may look all right when you just simply view them, but when you actually try to use those features in different types of geoprocessing operations, actually the fact that the polygon isn't properly closed causes the operation to fail. So sometimes there is a need, once you've obtained an extract of data from such a source, to actually do some additional processing of it to try and sort of check for issues like this. And the same kind of thing can happen in terms of the tags, the attribute data. You can get inconsistencies in how features are identified. So an area of woodland in one place might be identified by having the tag natural equal wood, and in another place it might have the tag land use equals forest. So if you're trying to piece data across an area, in effect across a number of different contributors, sometimes there is work that needs to be done to try and check for consistencies in how different sorts of features have been classified. So those are issues that you need to be aware of in terms of actually using the data. So let's now have a quick look at some OpenStreetMap data. So I'm opening up my web browser. I'm now looking at the University of East Anglia campus. I'm going to search for a different location. I'm going to search for Finchley in North London, and I'm going to zoom out for it for a bit. And the reason I wanted to select this area was because it's quite a nice illustration, and you can hopefully see it fairly easily straight away, that even within a single metropolitan area like this, there are some quite substantial differences in the level of detail that exists in different sorts of places. So for example, we've got this area here where if I zoom into it, you can see that there's this side of Hendon Lane. There is a great deal of detail. Every single house has been mapped. There is information on services on the other side. If we move the other side of the road, straight away we've only got the road network and much less detail about the sorts of buildings that are present. Same kind of thing happens if we go over to here. So this is closer to Hendon. So someone has mapped the detail of the RAF Museum at Hendon and the housing areas around it in great detail. And then you can literally go the other side of the railway line and straight away again you haven't got quite so much detail on the features that you're looking at. What you can do is sort of select individual features and then sort of look at how they're created. So we'll quickly experiment with this now. So this is the kind of query features option that you can see here. So we'll click on the park. Okay, so it's clicked on there, it's tried to identify different sorts of nearby features and enclosing features, and you can see that some of them are boundaries. If I click on where it says Woodcroft Park, it zooms in on that. You can see, firstly, you can see who created it and when they did, and sometimes that's really useful if you're trying to map these sorts of features. It shows you the nodes, it shows you the tags associated with the features and so forth. So if you want to query the data and understand more about it, this is a very effective way of just starting to get a quick sense of what the information looks like and gives you a sense of the kinds of things that you can do. If you want to access the OpenStreetMap data, there's a number of different ways in which you can do that. So if you want a relatively simple download of data, sometimes it's actually easier to get that from various redistributed data sources than OpenStreetMap itself. So one that we use a lot and has been proved very useful is a German website, GeoFabric. What has been done there is to take the whole of the OpenStreetMap database and essentially, put it into sort of sections so you can get data for particular countries or particular regions. And sometimes if you just want a set of data, that's quite an efficient source to use. You can, of course, download the data from OpenStreetMap itself. So if you go on to the OpenStreetMap website, you can click on the export button and you can define the coordinates of the area you want. And I would only do that for a relatively small area, and then you can export it. The software website will give you the option of downloading what's called Planet OSM. That is literally the entire OpenStreetMap database for the whole world. I wouldn't download that unless you really, really want to do so and you have the bandwidth and the file storage to actually cope with that. But you can see that, for example, there's a link to GeoFabric downloads, and sometimes if you only want a subset for a particular country or some cities, then those links there are quite good ways of sort of accessing the data. So that's a way of sort of getting at open source data, and for many types of application that is a really, really useful resource, and you can do an enormous amount with it now. Moving on, we can also think about different types of open source software. So we are now in an era where what's called free and open source software has become much more common. We have the ability to download software under a license that allows you to sort of firstly freely allow it for a purpose you want, but then more importantly, modify it, make modifications to the source code, and then freely distribute that onwards in terms of either the original version or a modified version that you've made. And this capacity for collaboration and innovation and update and so forth has stimulated all sorts of different types of software developments. And the GIS area is just one example of these. If you want to get a sense of how all these developments have sort of stimulated the innovations in open source software, one of the best places to start, I would say, is the OSGeo website. So there's an international foundation, and there's a UK link to that. So if we go to that website, this is the UK chapter of the OSGeo Foundation. You will see all sorts of information about, what they do and so forth. But the kinds of things that are really useful are the links to, for example, different types of software applications, geospatial libraries, metadata catalogs, different tools for web mapping, and so forth. If you want to get a sense of the different sorts of things that are possible, and this is probably one of the key resources to start on if you want to find out more about different types of open source GIS software developments. So there's a huge range of these different types of software. I'm just going to highlight two that are relatively widely used. GRASS, if you like, is very much the original open source spatial analysis software. It was originally developed by an engineering lab in the US Army. It was put into the public domain. It's gone through various sort of ups and downs in its history. It's a very powerful analysis toolbox. It's definitely not the easiest piece of software to learn straight away, but if you've got the capability and you want really advanced analytical tools, then that's a very good resource. The piece of software which I think has really started to become much more prominent around the world is a piece of software called previously Quantum GIS, now abbreviated to QGIS. It's easier to use than GRASS. It's more cross-platform. You can now start to access tools from software like GRASS from within it. So it's become a much better sort of window into a much wider range of different sorts of processing capabilities. And you could go to the OSGeo website or just search engine, look for QGIS, and you would find details of it. So what I'd like to do now is just give you a little demonstration of some of the kinds of things that you can do with QGIS. So this is just a screenshot showing a particular data set that we put together for part of Essex. So I'm just now going to switch to the QGIS software. So this is the QGIS software window, and you can see how it's displayed. I am using version 2.12 of the software because that's the version that we've currently got installed on our university infrastructure. There are more recent versions available for download from the QGIS website. What you see here is a software structure which, if you're familiar with something like the Esri ArcGIS software, it's not too difficult to sort of map across in terms of terminology. So you have here in the top left the browser panel. So in many respects this is quite similar to the sort of Arc catalog application in ArcGIS. The layers panel that you can see down here is very equivalent to the table of contents in ArcGIS. You have an overview panel here, and the view that you can see here in QGIS speak is referred to as the map canvas. In ArcGIS speak, it would be the data view. There are a huge range of other panels and toolbars that you can load into the software. If I right-click on the menu toolbar, you can see now on the screen the sheer range of different sorts of panels and toolbars that exist, and there's actually many, many more. One of the very definite strengths of this software is now the extent of the sort of plugins and customization that's now available, and that's very much a reflection of how the sort of QGIS community has grown and evolved in the last few years. So you can have all these different toolbars switched on and switched off depending on what you want to do. The data set that you can see displayed is one from a project that we're doing as part of the data center's work, and we're looking at methodologies for mapping green infrastructure to do this on a scale that's not just at the level of one local authority, but across entire regions and hopefully ultimately across, for example, the whole of England and Wales. And we're doing that by looking at how you can combine together different sorts of data sets, some from organizations like the Ordnance Survey, others using features from resources like OpenStreetMap, and linking them together to identify different types of green infrastructure. So one of the pilot areas that we worked on was the local Basildon Local Authority, and you can see in the legend here how we've identified different types of green infrastructure in that area. We've used other open source data sets from the Ordnance Survey here for roads and urban extents and so forth. If we want to sort of look at a layer in a little bit more detail, if we right-click on it, we can open the attribute table for that layer, and so you can see all the different types of features. So in this particular example, because the layer you're seeing actually comes from a range of different sources, we have a column identifying where, for example, the features came from master map, or where they came from OpenStreetMap, and what they represent, and all these different sorts of things. So once we have a layer like that, we can also, for example, zoom into the map, use sort of interactive features in ArcGIS, in QGIS, sorry, and select a feature. We should be able to sort of select a feature and then view what's going on here. Okay, I'm having a few slight issues here, but the point is that you could look at features both in terms of how they appear in an attribute table, and you could select them interactively, and you could work with them in those sorts of ways. You have a very large range of different sorts of vector and raster formats that you can work with. So for example, if we want to load in different types of vector data and we browse, you'll see the different types of formats that we can access. So the software is extremely good in terms of the range of formats that it will import natively. If there's a format that you also need to work with, such as, for example, ESRI file geodatabases, which are not supported natively, there's actually a plugin that would let you do that. So you can work with a huge variety of different types of raster and vector data, and you can import those. So again, okay, this is tables. That would be raster layers, and again you can see the very, very large range of different file types that are supported. You also have quite a substantial range of different types of analysis tools. So you can just see these from me flicking down through the menus, the different kinds of things that exist for vector analysis. Same kind of thing is true for raster analysis. So I think one of the key attractions of this software to many people now has been that with a free piece of software like this, you now have a very, very large proportion of the functionality that you would get with a piece of commercial GIS software like ArcGIS. And so very clearly that is putting pressure on the commercial software providers to change the kinds of offerings that they have. The other real strength of the software is the ability to load and run in all sorts of other plugins. So there's a kind of QGIS plugin sort of repository, and you can see this huge range of different sorts of extra plugins that you can load. And there's some fantastic different types of functions here. There's a huge range of different types of things that you can use. One of those that I've found particularly valuable is a plugin for what's called open layers. And the nice thing about that is that then lets you bring in, for example, data from the sorts of resources that you can see here, like Google Maps, Bing Maps, OpenStreetMap, and so forth, and use that as sort of backdrop. So we could bring in, say, from Google Maps, satellite imagery for the area, and if I move that down my sort of layers panel, you can now see the different sorts of features I was looking at on top of the satellite imagery. So it's very, very easy to bring in these different sorts of capabilities and work with them. And if you want to design maps for map production, you do that with the map composer, so print composer. And you can make a very simple basic map just by sort of having a canvas there, drawing an area, bringing the information onto it, and so forth. So there's a lot of capabilities that you can build into something like that. So I've tried there to give you an overview of the sheer range of things that you can start to do with software like this. The point I'd like to finish on is the way in which these sorts of capabilities are now beginning to be possibly linked to all sorts of other types of tools. So in the presentation today, I've focused very much on the idea of, say, different types of open data going into a desktop GIS like QGIS, possibly with the GRASS tools. But you can see all sorts of other ways in which this kind of software configuration could involve in the future. So, for example, there are all sorts of ways in which you could integrate these tools with statistical analysis tools such as the R language. If you needed to handle data in very large relational databases, you could use tools like PostgreSQL. And you have new ways of actually creating different types of outputs, and particularly the ability to create different types of web mapping outputs using software like OpenLayers. So these kinds of configurations here are all using open source data and open source software, and they're, if you like, in many ways democratizing what it's possible to do with these types of tools. In our situation as a university, we have been teaching software like Esri's ArcGIS for a long time, because that was the most useful thing for our students to have in terms of items on their CV, in terms of career development and so forth. But it's very clear to us, based on discussions with all sorts of people in the last few years, there's a lot of interest out there in expertise with these types of open source databases. So we have altered our GIS teaching, so we deliberately now expose the students to OpenStreetMap and how you can take data from it, and we're now starting to teach them tools like QGIS and so forth. And we can see that many other universities and many other large organizations are also moving down this kind of path. So the GIS world, in terms of the sorts of data and software configurations that you're working with, is, I think, going to be very, very different in another 5 years' time to what it is today. So I hope you found that interesting. I hope it's at least given you some ideas about where to look for further sources of information. And if you've got any questions, I'm very happy to do my best to try and answer them. We may have a little bit of time to do this now. If you've got other questions or you'd like a little bit of additional information, you can see my email address on the screen, and you're very welcome to contact me. Thank you.
Thank you, Andrew. That was brilliant. We've had one question come through. So presumably OpenStreetMap is a representation of the physical world. Can theoretical layers be rendered onto it, for example, to show the differences between the physical position of a footpath and where it should be if you refer to the definitive map used by public rights-of-way?
I think you'd have to take the data out of OpenStreetMap and bring it into a separate piece of software like QGIS or something like that to do that comparison. You could download the footpath data from OpenStreetMap and compare it with other things. It wouldn't be easy to do that comparison straight away in OpenStreetMap.
Okay, brilliant. Thank you, Andrew. So I think that's all we've got time for today. So thank you for joining the webinar. If you would like to attend another session and you're from the public sector, Andrew is actually running a session at the University of Essex on the 13th of January on data linkage techniques with GIS. So I have just sent the link there if anyone from the public sector would like to attend that. But thank you, Andrew, again for this session. That was really interesting. And the slides will be made available on our website soon if you'd like to look over those again. So thank you.